Now, I just love these cassettes. These Commodore 64 cassettes, not all of them, but a good few of them defined the 80s and 90s for me. Getting out a cassette and loading it is a tremendous nostalgic value to me. And something that I was thinking about recently is what we used to do a lot back in the day, is cram a lot of these onto one 90-minute cassette. But how many games, if you did it properly, how many games can you fit on one cassette? That's what I want to find out. So what I'm going to do is load up a few of these, extract the program data from them if I can, and compress it, best compression possible, and ditch it back onto the cassette and see how many games one cassette can hold, which not only is convenient for having many games stored on one cassette, but it'll also shorten the loading time. Some games, we always used to say, some games take half an hour to load. I think that was a psychological thing because you were always waiting for the damn thing to fail loading. But many games did take upwards of 10 minutes, however. So it'd be interesting to see how many games I can get to fit on one cassette. So that's what I'm going to do. I'm going to be loading them up from the original cassettes out of my stash of around 500 tapes here. Using the action replay to freeze the action. And rather than do a backup using the built-in backup maker on an action replay, what I'm actually going to do is I'm going to be using the machine code monitor to try and find the exact beginning point of the program and see if I can make a proper copy of it, not something that starts 5 seconds after the game program's run, because I always found that a little bit annoying, you see. So that's what I'm going to do. It's going to be a long process, might even go over several videos. But we'll see, we'll see what results we can get and do some comparisons with the new copies against the loading times of the old copies. And then if I have time at the end, I'll put the same programs maybe onto a 1541 floppy disk and load them up and compare the times with and without fast loaders. We'll see what we can find out. So, okay, so I'm going to start off with the game Bounty Bob Strikes Back. So here. So let's see what size we can get this down to. First of all, just let me check my disc, make sure that the disc has nothing on it. Okay, no, we've got a nice blank disc there. And I'm going to load this in from tape now. Right, what I need to do is freeze the action using the action replay cartridge just before the game starts, but I need to try and get it just after the loader has finished. If I freeze it during the loader, it's very unlikely that I'll be able to get it to resume afterwards. So what I need to do is freeze it right at the last minute, and then have a look at the machine code monitor and see what we can find. Okay, I'm nearly there now. What I need to do, one way of confirming that the load is finished, when the music starts to fade out, I'm going to freeze it right when the music's fading out. Right there. Now we can stop the tape. Okay, so we're straight into the machine code monitor. And what we're going to do first is check the memory to see at what location. Just paused here to mention what it is I'm actually searching for here. When games load, they often disable the built-in ROMs, which are your basic kernel and character ROMs, so that they can use that space in memory while they're loading and things like that. And to do that, all they do is they set position 1, memory position 1 to a 34 from its normal 37, which basically means free up this memory space, get rid of the ROM so that we can use it. And one of the last tasks that the loaders often do is they then re-enable it just before the game's launch. So you can track them down by searching the lower areas of memory, like from 0 to 800, for the command or the instruction which sets the memory position 1 back to the 37. So that's what we're going to be searching for here. I thought I'd better just get in and add that. The ROMs were about to be re-enabled And to do that, what we do is we do H, which is for hunt, which is basically a search, and then you need to give it a start address and an end address. So we're going to go from memory position 0 to position 0800. So what we look for is A9, which is for basically store a value in the accumulator, and the value that we're looking for is 37. And then the following instruction should be to then store the value of the accumulator in memory position 1. So that's what we need to look for. And straight away we've got a result there, 03 double E. So I'm going to write that down. So let's have a look at what's going on at 03EE. I'm going to disassemble that. Okay, we can see the instruction there. Store value 37 in the accumulator. What else have we got? As expected, the 8501, which is store the value in the accumulator in memory position 1. Jump to a subroutine. Make a jump to a different location in memory, an indirect jump. So that looks like it's going to be what we're looking for. So we've got R3 F5, jump, indirect, R7 B E. So in order to make a copy of this, what I need to do is I need to stop the program from running, and I need to freeze it right on the very edge, just before the program runs, because I don't want to capture the data after the game program has already started running, and I also don't want to catch any of the loader still present. So what I need to do is prevent the program from running, and then dump it right at that very moment when it's just about to run. So there's a couple of ways we can do that. This is going to be the instruction that does it. We can either change this jump command. I could change it to something like this, R3 F5 jump to memory position, or 3 F5. That would create an endless loop. It would keep looping onto itself, and that would give us the chance to freeze and then dump it to disk. But the action replay conveniently provides us with a better way of doing that. All you need to do is go up to the instruction that you're interested in and change the first hexadecimal value. Say we've got 6C here, change that basically to SF, which is set freeze. So what the program will do when you resume it, it will continue where it left off, and then when it gets here, it will freeze and bring us back in. So I'm going to do that now, and then we can go back out of here. So what I expect to happen now is the program to resume to the US gold screen, and then maybe a second later bring me back into the freeze screen without me actually pressing the button. There we go. So now you can see we're at the instruction 03F5, which is the one that I wrote down here. And if we now check 03F5, the action replay has kindly changed it back to the 6C, which is what it was originally, which I know that a 4C is a jump, a direct jump, so I'm guessing 6C is going to be this indirect jump that we've got here. And an indirect jump is when we have it in brackets like this. Rather than the program going from here directly to this address, R7BE, what it's telling the program to do is to jump to whatever location is held at R7BE. So the program doesn't actually pick up from R7BE, it just gets the address from there. So in order to know where we're going, we need to check what we've got stored at R7BE. So I'm just going to do a monitor of R7BE. And as you see, we've got in the first 2 bytes here, we've got 642E. That is going to be our address, 642E. And it's actually in low order bytes, so it's actually going to be 2E64. I'm guessing. 2E64. Okay. So 2E64 is the start of our program, but before we do any of that, we need to dump this to disk. So what I need to do first is just check whether our ROMs are enabled or disabled. So our ROMs are enabled at the minute. So Let me just check. Bits, I need to change that to a 34. That just ensures that we're not going to make a worthless copy of the ROMs in addition to the game program. So now we can do an S save. I'll just call it BBSB 8, and then we need to give it a start address and an end address. Now there's no point in us going any lower than 800, and we'll save it direct to the very end of memory. Okay. Okay, there we go. And just to confirm that that address is the one that we were looking for, and now that the program save has been done, I'm going to do a go 2E64. So this should actually run the program for us. If it's not, then I've got the wrong address there, and I'll probably record the video again. Nope, success, there we go. So 2E64 is definitely the starting program. Just make sure the game runs. Yeah, looks good to me. Perfect. So let's try loading that back in from the dumped copy now. Let's just make sure that we actually got something saved on the disk there. Yeah, we've got a 250 block program. I know that seems quite large now, but I'm going to be compressing that afterwards. So we've got the BBSB. So I'm going to go into the freezer screen. Nice, kindly takes us straight to the machine code monitor, which is handy. I'm going to do a load. BBSB 8. Just that. I'm actually hoping that my new tape copy of this will load straight into the game faster than this. Faster than the infamous 1541. Okay, so that tells us we've loaded, so I'm going to exit now, and I could just from the machine code monitor tell it to go straight to that address again, but whilst I'm at it, I'm just going to convert this 2E64 back to decimal, and we should be able to get there from the basic screen. So if I just clear the screen there, and we've got, what is it, 2E64. So we can convert this to a sys command, just by converting that hexadecimal number to binary. And just in case you didn't know, and just to remind myself basically as well, the way that you convert these is the end number here is the units, so you just add that on. This number is whatever that is times by 16. This number, I think it's by 256 maybe, and then this number by 4096. I may be wrong about that, let me just check. So we've got 16 times 16, yep, 256, and then 16 times 16 times 16, 4096. Yeah, that's right. Okay, so what have we got first then? We've got 2 times 4096, so that's our first number. Then we've got E, which is translates to decimal 14, I think, times 256, so that's 3584. Then we've got 6 times 16, 96, and then we've got the 4. So let's try 4, no, 8192 plus 3584 plus 96, and then we finally add the 4 off the end. 11876, that's the decimal conversion of 2E64. So just to test that theory, if we do a sys 11876, that starts the game up for us. So I'm happy with that. That's a perfectly dumped copy directly at the start of the program, no loader included, and not missing any of the beginning of the program. So I can now get this program onto the PC and compress it, and then we'll look separately at writing it back to the blank cassette. Brilliant. Okay, so here I am at the PC. So what I've got here is the Bounty Bob Strikes Back PIG file. So what I had to do was copy the file from the 1541 disk to my SD2 IEC device, and then I've brought that SD card over to the PC and I've got it in a folder, which I'm now going to use to compress the file using Exomizer, which is an excellent compression tool. And I've got a blank D64 file, and what I'm going to do with that is, once the file is compressed, put the compressed version into the D64 file and then test it in an emulator, and if all is well we'll take it back to the physical Commodore 64 and see if we can get that written back to tape. So we've got a 63K. Obviously I saved almost the entire contents of the Commodore 64's memory during creation of that dump. So this is now going to compress all that empty space and give us a smaller file. So here we go. We're going to run Exomizer, and we're going to run it in SFX mode. So that means it's going to decrunch itself once the file is run on the Commodore 64. We can give it a start address, and since we know from the machine code monitor, we know what the starting address is. It is 2E64. So that means you won't need to issue a sys command or anything like that. It already knows what it is. As soon as it's decrunched, it will run. And then we'll give it an input. Excuse me, give it an input file, which is obviously bbsb.pig. And -x2 means it will show the flashing raster bars during decrunch, and outputs bbsb. Call it new.png. Okay, so that's going to compress the file. Done. Okay, and we now have BBSB new, which is 36 kilobytes in size. The original one was 63, so we've lost quite a good chunk. So I'm going to copy that over now into my blank floppy disk, and we can see there that uses just 144 blocks, whereas the original one was 250. So it's quite a significant saving. So I'm going to save that, and I'm just going to load that up in Vice as well, just to make sure before I take it back to the Commodore 64 that this is actually going to work. So let me just try dragging it in first, see what happens there. Bam. Okay, I'll just do it now. In warp mode. So this is the Exomizer decrunching screen, which is good. Providing that start address was correct, the game should run. Excellent, there we go. Happy with that, so do a reset there. So now what I'll do is I'll copy that D64 back onto my SD2 IEC, and we'll head back to the Commodore 64 and transfer it to tape, see how many blocks it takes up. Okay, so let's get this transferred back to cassette. I'm going to do this directly from the SD to IEC. Not really any point with transferring the file back to a floppy disk. Okay. To do this, I'm going to use a program called Gyrospeed rather. And Gyrospeed is an old turbo tape loader that used to use back in the day to increase the loading times on games. Did a bit of compression on its own, I think, but nothing compared to some of the compression routines we have today. So, but it comes in handy just for the sake of writing files from your disk back to cassette. Okay, so we'll do F1 load a program from disk. We're just going to do basic program. Load from disk, and the file name was BBSB. And so, is the file name to be different? Yes, I'm just going to name it Bounty Bob. And press space. Okay, so we have it loading from SD. It's going to take a minute or so. Okay, the program is loaded. Press space for menu. So we're back here. F3 save program to tape. Press space when ready. Record and play. So here we go. C90 cassette. Let's go. What do I always forget? SD to IEC take the power from the tape connector, so I'll just have to swap that over. Okay, take 2, here we go. Okay, we're up to 30 on the counter so far. Oh, 31. Okay, so we can quit this. Stop the tape, let's rewind that. Start from scratch. Let's give it a go. Definitely saved, that's good.
The music bed.
Okay, tape has finished loading, we're at 31 on the counter. Sequence is running. There we go. Perfect copy of the game, gone from cassette, skip the loader, full memory dump, written to disk, compressed on PC, back to SD to IEC, and then finally written back to cassette using Gyrospeed. 31 blips on the counter. Unfortunately, I didn't check what the counter reading on the original tape was, but I know it was a lot more than that. I'll test afterwards and report back. Excellent. 31 on the counter. That's the time when the new copy of the game finished loading and was running. It was on the set. It was showing 120 watts to load. So let's just see what we get up to on the counter. Okay, there we go, 74.